Welcome. In today's SPSS session, we'll be discussing one sample t-test and two sample t-test evaluations. To begin with first, that is one sample t-test. This is useful for an example if you are checking the average exam marks for English, maybe checking whether it is equal to 50 marks. So for an example, if you are proceeding with such an analysis, first you have to check for normality and outliers. For that, you have to select Analyze, Descriptives, Explore, then select particular subject. For an example, we have select this one, and this varies from 1 to 7. So we will be checking first whether this variable satisfies normality distribution and non-availability of outliers. For that, select statistics and check outliers, continue. In plots, you have to select normality, continue, then press OK. Here you will be getting descriptives, and mean is somewhere around 4.8, and you have to refer skewness and curtices. This should be somewhere around 0, close to 0, as these figures are deviating. For that, this is not a normally distributed variable. So in percentiles, this says 50% of the responses are below 5 and 50% are above 5, and these are extreme cases related to mostly outliers. And normality test, as we said earlier, both the case and SW tests are significant. That means distribution is not normal. It is evident in the histograms, leaf output, and also in this QQ plot. Here we have seen there are outliers, and if you want to proceed with one sample t-test, you have to exclude outliers, then you can proceed with this one. Otherwise, you have to go for non-parametric tests. So imagine that distribution is normal, then of course we can go for one sample t-test analysis. So for that, select Analyze, compare means one sample t-test. We are taking this one, 95% interval, and here we have to include test value. And as we said, marks are between 1 to 7, so we will be considering 3.5 as average and press OK. Then test output is given, mean is 4.8, and here this is significant. That means marks, average marks, not equal to 3.5. It could be either above or below 3.5. As this is two-tailed test, we can't say whether it is above or below. However, as the mean is 4.8, we can assume average is above 3.5, and non-significant test is witnessed by this difference low and upper marks here, and all those are in positive side, so that this is not significant. Even it is, if the both low and upper bounds are in negative side, that also gives significant results. That means mean is not equal to 3.5. So we can run this analyze again, compare means, one sample t-test, and here in this case we will be selecting 4.8 as our average value. So once we select that, this is not significant. That means average is equal to 4.8. As we have selected figure close to 4.83, this is non-significant. That means average is as per our 4.8 figure. And now the lower and upper boundary for difference crosses 0 mark. That means results is not significant, and that what we have tested is whether it is equal to 4.8 marks. So it is 4.8 marks. Next thing what we are testing is individual 2 sample t-test. Here in this test we are checking, for an example, whether average English marks for males and females are equal. That's what we are checking. Average English marks for males equals to average English marks for females. To run this analysis also we have to satisfy normality and non-availability of outliers. For this also we will be selecting analyze, descriptive statistics, explore, then we will be selecting our variable. Under statistics select outliers, under plots normality again. Here we have to select gender or sex as factor is. Now we are checking for both the males and females, so we have to select factor as gender or sex, then proceed OK. Now we will be getting the output, and we have to refer for outliers and normality as we checked earlier. Here descriptive statistics are given for both males and females. Average is somewhere around 4.87 for males and 4.85 for females, and this indicates that average is almost the same or equals between these two males. Even if you straight away go to test, that means here if you go and see the test results, you will identify if you run the test. Now we will be running the test after a while. So just imagine now for males that is 4.87, for females 4.85. This is almost the same. So once we run the test, most of the time we will be getting null hypothesis is correct. That means there's no significant difference. So keep in mind, for the time being we will be analyzing whether there are outliers and whether these two distributions are normal. So just refer, extreme cases are there. Normality test for SW and case test both are significant. That means these are not normally distributed. So we have to adjust by way of excluding outliers, and we have to run this again, or else we have to opt for non-parametric test. Just imagine this is normally distributed, and so that we can go for 2 sample t-test. For that we will be selecting analyze, compare means independent sample t-test, and here we will be selecting this one, and we will be getting grouping variable, and where that is gender, and we have to give group numbers, that is 1 and 2, 1 for males, 2 for females, and we will do continue. After defining groups we have to continue. Then in this output, first assumption is normality and outliers. Second assumption is population variance is equal. That means to decide that you have to refer Levine tests for equality of variance. that means this is 0.572, meaning non-significant. That means we have to go by the null hypothesis, that is population variances are equal for males and females. So if this is non-significant, we can proceed with t-test for equality of means. Here tests values are not significant. That means we have to accept our null hypothesis, meaning there's no significant difference between males and females. That is further evidenced by difference related lower and upper boundaries. It crosses, these figures are crossing 0 mark. That means this is not significant. So that it implies that we have to take that null hypothesis, indicating there's no significant difference between males and females as per test results. And what does this means is equal variance not assumed means if you are having large sample, under central limit theorem we can proceed with this one, and it assumes normal distribution. If you are having a small sample, we have to go by equal variance assumed figure. So for this two sample t-test analysis, we have to satisfy mainly three things. First one, outliers. Second one, normality. Then we have to check population variances whether equal or not. For that you have to refer t-test output and refer Levine test. With that we will be concluding today's session. Thanks for being with us.